Hi, my name is Pranav Sanghavi. I'm a graduate student at West Virginia University. Shall be talking about tone, an 8-dish array that serves as a CHIME FRB outrigger testbed. It is located at Greenbank Observatory, and it works along with CHIME FRB and the Algonquin Radio Observatory 10-meter outrigger to achieve milli-arc-second localization of fast radio bursts. They are built using off-the-shelf 6-meter dishes. 8 of them are commissioned with the analog chain and data acquisition systems completely operational. They operate within 400 to 800 megahertz. That is the chime frequency range. The dishes are instrumented with dual polarized cloverleaf antennas that use a mix of chime and Hyrax design versions. The primary beam has a nominal full width half max that ranges from 5 to 10 degrees within the 400 to 800 megahertz frequency range. The analog chain comprises of an LNA and an RF over fiber transceiver system. The digital backend consists of the ICE boards that digitizes 16 analog inputs and further uses the FPGA to channelize the 1024 to 1024 complex voltage channels. The triggering and timing of the ICE boards is done using a GPS clock, and the GPS clock is characterized using a maser signal from the Greenbank Observatory. The data is transferred to a recorder node over 240 gigabit Ethernet connections, and the data acquisition is managed by Codecan software. So an FRB detected at CHIME goes through the real-time detection system. If that FRB is within the tone field of view, or if it's a crab pulsar, it sends a trigger to tone. On the tone side, the analog signal that is digitized and channelized is sent to the data recorder, which is continuously saved on a very large buffer that is 40 seconds long, utilizing 500 gigabytes of high density RAM. Once the trigger is received, it is saved to disk. About 500 milliseconds of data of channelized voltages at 2.56 microsecond cadences. The n-square calibration to beamform the array is achieved by utilizing the crab pulsar triggers, and the data from the crab nebula is used to calculate the gains. The beamform data from CHIME and from tone is then correlated in using a custom built software that we did along with a group, and further localization routines provide us with sub-second localization, all the way down to the theoretical 50 milliarc second localization of the FRB. Tone has received almost daily triggers from the crab pulsar since February 2021. We have also received triggers from one of FRB that has not known to repeat. For results for the system about localizing the FRB, tune in to Calvin's, my colleague Calvin's talk during the radio stars transients and pulsar session. Thank you very much.